Oh, I forgot the intro. You know what? Let's just run back and do it. All right. Welcome, everybody, to another SST weekly stream. So today we have something pretty exciting. We're going to be doing a video on tRPC, what it is, why people are talking about it, why it could make sense for your project, and of course, how to use it with SST. So I've actually never set it up before. So this process, we're going to go through the docs and kind of do it all together and learn how to do it. I do know it's possible. There was a great article that someone from our community, Magnus, wrote about getting tRPC working well with SST. That's what I've been using to link people. But I've never done it myself, so I kind of want to go through the process. So yeah, that'll be the video for today. So let's get started with a little bit of background around what tRPC is. So as you can imagine by the name, it is an RPC framework. So the question is, what is an RPC framework? So RPC stands for Remote Procedure Call. All this means is you have a client, like a web application, mobile application, whatever, and they want to call some functionality that is somewhere remote. So in a web application situation, you obviously have some functions that need to run on the server, stuff like inserting stuff in the database, things like that. The idea behind RPC is that you think in terms of commands, as opposed to something like REST, where you think in terms of like resources and the typical REST structure where you can list a resource, you can get a resource, you can like post, put, patch, etc. I think it's actually, so with RPC in general, I think it's a really great fit for most projects. If you are going to do REST, you should do something like JSON API, which is a very opinionated way to do REST that helps you have structure around here's how you model relationships, here's how you model various different things that occur in a REST environment. I found that most companies don't do anything close to JSON API. It's kind of like a mishmash of a bunch of different REST endpoints that are very purpose driven. Like for every new feature, they might ship a new REST endpoint that does a very specific thing. In situations like those, REST is kind of overkill and you're not really using it correctly. You might as well just use something like RPC, which is more natural to what the way that you're thinking, right? You're thinking in terms of, I have various functionality that exists on the server, and I'd like to call into it from the front end. This functionality will take some kind of input and return some kind of output. The fact that it's going over HTTP to some kind of like REST-like endpoint, that's not really as important in that situation. So I think for a lot of like internal APIs, this could be a great fit. So the question is, what about GraphQL? Because we talk a lot about GraphQL and we've invested a lot in GraphQL. GraphQL can also be thought of an RPC framework, right? You have different types of commands you can send up, broken up into queries and mutations. The thing with GraphQL is there's a more opinionated layer on top of the pure RPC side of things, right? You have types that you can define. These types have relationships with each other. There's a lot more that goes on besides pure, I'm calling a remote function somewhere else. So GraphQL is great when you need to express a complex graph to a client. This can be in cases where I think a lot of mobile apps benefit from this. A lot of web applications that are more like SPA applications that are up for a long time. You want to take advantage of things like normalized caching. You want the front end to be really aware of all these relationships and sync them back and forth. GraphQL is a really good choice there. But if you're not doing something that heavy or intense, an RPC system is usually what I like to fall back to. So let me check my notes here. Okay, so that's generally about RPC. Now, the question is, what is tRPC? So tRPC is a specific RPC implementation that is focused on full stack TypeScript. So if you're using TypeScript on the front end and you're using TypeScript on the back end, can we make this process really smooth so that to the front end, it feels like you're calling just any other function, but it happens to be running on the server? And there's lots of interesting things that you can do there, like validations to make sure that the stuff coming from the front end is formatted correctly for the back end. But most importantly, it can do end-to-end type inference. So with our GraphQL setup, it feels like you have end-to-end type inference, and practically you do. But the way this works is whenever there's schema changes on the back end, we run some code generation, and that generated code is what's being used on the front end. When it's integrated as deeply as it is into SST, it feels pretty good, and you don't really notice any kind of delay or any kind of awkwardness with that. But in general, code generation steps are kind of clunky. With tRPC, there is no code to generate on the front end. The way it works is you define all the commands you can do on the back end, all the functions you can call, what types of things that they return. You actually need to specify the types, and that's really important. tRPC is very good about using inference over specific type definitions. So you will have to explicitly define like what arguments your function takes and how to validate those. Whatever your function responds with, tRPC can infer that. So in your front end, the responses there are fully typed. And this does not require a code gen step. You can basically import the type from the backend code into your front end code. This type only exists during development time. Once your front end is built, there actually is no backend code being built into it or anything. It's just talking to the backend over a normal HTTP endpoint. So this is purely about making the developer experience, really good. The goal, like I said, the goal is to feel like even though you're in front end code, it feels like you're calling just any other backend function. So let me see my notes. Oh, another thing nice about tRPC, so they have plugins not plugins, like adapters for whatever front end. Specifically, if you're using React, it's built on top of React Query, which is a really great library for doing anything asynchronous. So the fact that your front end is calling a function on the back end, managing the fact that it's loading, things like that, it's all built into the tRPC client. So that's a general overview. So to summarize, if you don't want to go the GraphQL path because you feel like it's too heavy for the application you're doing, you're not really going to take advantage of the relationships and all the normalized caching stuff you can do. tRPC is a great option. I think for most cases, I don't personally see why I would ever use like a typical REST setup. If I want to do something, if expose like a graph of data, I'm going to go with GraphQL. If it's something more simple, or something that I'm not taking advantage of those things, I'm going to use tRPC. Maybe potentially if I'm exposing a public API and the consumer is expected to be REST, I'll probably use REST. But other than that, between GraphQL and tRPC, I feel like the range of things I would build are covered. So let's jump into setting up a new project with tRPC. So earlier today, I bootstrapped. This is the wrong project. So I've been getting better about saving these repos from the SST Weekly so that they'll all be collected on GitHub. So we do have this new SST Weekly repos repo, which I guess is a bad name. It should probably just be called SST Weekly. And in there, I'm making a subfolder for each stream with a date on it, so you can go and take a look at whatever I do, and I'll just commit everything after the stream is over. So I made a project earlier today. It's just using create SST with a minimal configuration since we don't need all the GraphQL stuff. And we'll get started by configuring it. So the minimal configuration comes with an API. So the way tRPC is going to work, it's kind of very similar to a GraphQL handler. You're going to specify a single function that's going to handle all tRPC requests. And that's just going to be like any other route definition. So let's get started with pulling up the tRPC docs. And I'll make this big so everyone can see. All right. So they do have, I did see they have a Lambda flow. So let's actually just go through this. How we're going to lay this out. Let me open up a terminal here. Make this big. All right, I want you to be able to see this. Okay, so first step, let's install tRPC server. So we'll go into services folder, yarn add tRPC server. And then from there, we will create a new function called tRPC. And let's set up, looks like a new tRPC router. So let's import. All this working. Okay, it is. All right. Yeah, the autocomplete stuff is going to be really important for this because the whole point of using tRPC is to get great autocomplete. So you can see here they're also using Zod. So if you're not familiar with Zod, it is a great library. It's in the category of like truly TypeScript native libraries where they really rely heavy on inference and give you a really great experience. So Zod specifically is for validation. So you can define the shape of data, validate it, get proper inferred types. tRPC integrates really nicely with it. It doesn't require you to use Zod, if I remember correctly. I think it integrates with other validation libraries. Zod is my favorite, so that's generally the one I recommend and use. Let's install that real quick, and then we'll use this example. So we'll do a router, so tRPC router. This is going to be a really simple example. Let's make a new query called hello. So tRPC is similar to GraphQL in that it splits its commands between queries and mutations. So the idea behind queries is you're fetching some data. The idea behind mutations is you're taking some kind of action. So let's make a simple query that just echoes back whatever you send. So you can see here I'm saying this is using Zod. I'm defining that the input needs to be a string. You can use Zod to describe any kind of object. So you can say like, this is an object with a field called foo. That's a string that needs to be an email, et cetera. But for now, we'll just do string. And there's a resolve function. So kind of similar to GraphQL, right? You write your resolver. Since I'm looking very similar to Auth, I think. And if you look request input, you'll see that this is a string. It's inferred because, tRPC will use Zod to make sure the input's valid. And at that point, it knows the string. If we change this to number, this will be number. Okay, so let's just, looks like it's kind of doing something similar. So let's return an object message as you said. Okay, so this is all you need to define a single command. And this part's important. So we're going to export a type that represents, this is a thing that the front end is going to import so that it can actually use this. So expose a type router, and we can do type of. Cool. Let's scroll down. So now we need to define our actual Lambda function. And tRPC looks like provides an adapter for this. So let's just pull this out. They also have this concept called context. This you can use this to pull out auth information so that this gets passed into every request. I think this will have a context, and you can give it a specific type. We're actually not going to configure it, and for the most part, you shouldn't need this, especially with our context library that's coming up. You can kind of do this in a non-centralized way. So for now, let's just do export const handler, AWS Lambda request handler. The router is the router. Context is optional, so we are not going to do that. And that is it. Okay, so if we, this can be a get endpoint, so we can actually use this we can actually test this without the front end pretty easily. Two different formats for REST APIs 1.0. Okay, looks like this should work with both the 1.0 and 2.0 formats. All right, so now that we basically built our function, now let's mount it to a route. Oh, I should also start this, shouldn't I? RNSC start profile. I think I logged in earlier, so it should be fine. It's going. We'll let this go. So let's go to our stacks. I also threw in a front end, a simple React front end here. We'll probably use that later to wire everything up. So let's just do any. And I'm going to show you something specific that is helpful for tRPC. So we're going to say the tRPC path is at /tRPC, but then we're going to do this. So what this means is that any route that's starting with tRPC will be passed to this handler. The reason we need to do this is the source of truth for your various queries is going to be in your function code. So yeah, you can like explicitly list out every single command you have here and map it to the same function. But I think the simplest place to get started is by just having a single route that will just forward everything to the tRPC handler. So question comes up a lot with, is there a way to avoid having like a big model function that grows bigger and makes your cold starts worse? So yes, you can start to extract out some commands into their own tRPC function. So if you have something that, if you have just like one command that uses some really big dependency that's slow and you don't want that slowing down all your other commands, you can have that as its own tRPC router and have that as a separate function that gets called separately. But for now, we'll just route everything to a single tRPC handler. We gotta wait for this to deploy. Let's see what we can do while waiting for that. Actually, don't know if there's anything we can do. Let me get the front end going just so make sure we don't have anything messed up there. The reason this is slow is we're deploying a new route. This should, again, really only happen once in a while. Shouldn't happen all the time. Okay, so we got our new front end, which is a Vite React app. That looks good. We'll jump to the tRPC React section after we just verify that this is working. Yeah, I guess in the meantime, we'll just show some stuff here. So the reason I'm actually familiar with tRPC is we started using it a long time ago, just internally within SST. And we're actually mentioned here in their docs because we're an open source project using it. Looks like Alex merged my PR to fix this with our new branding. Cool. So yeah, so we use tRPC to talk to. If you use our console for SST, that console talks to the CLI using tRPC. The reason we use this is, again, is a perfect fit. tRPC also supports subscriptions over WebSocket. So you can also define commands that subscribe the client to things and you can send updates. We don't have a working example of that with like an actual, with SST, with going through AWS infrastructure yet. We will put that together eventually. But we were using it internally for our CLI. It was perfect for that use case. And tRPC got bigger, and we're starting to get more questions around using it for typical web applications. And that's why I'm doing this video. Okay, so it looks like this deployed. So if we take a look, that's hitting our root thing. tRPC hello. Let's see if this works. Okay, so this does work. It's hitting our tRPC function. You can see we're getting a really nice error message here saying, you didn't pass in an argument that you needed to pass in. So invalid type, we expected a string, received undefined. So let's see, I think we can do this just by going like input equals hello. This needs to be JSON. Yeah. Okay, you said hello. Nice. Bye. Okay, cool. So the tRPC stuff is working on the server side. It's pretty simple to add more queries here. We'll say, bye. Do something a little more complex here. We'll say, we'll say input needs to be an object where there's a message, which is a string. And to resolve it, request input. So you got the message right there, and we'll return kind of the same thing. And if you go here, now we can do bye. And this needs to be JSON. Again, this is a little awkward because we're manually typing this out, but this typically shouldn't be what you're doing. So I said it needs to be an object with a message key. Unexpected. Oh, I'll put quotes around the whole thing. And I mistyped the procedure name. This is actually a great example of why end-to-end type safety is great. Look how much I'm messing up while I'm trying to manually build this. And we're going to see how simple it is when we're using end-to-end type safety. So hit buy, refresh. All right, everything's working. So you can see how once you have this set up, this can be really productive. Anytime you need a new server-side function, you just add something here. This can also be split up into multiple files, so you can stay organized. So yeah, I think that's it for the queries. Let's now, on the front end, let's start the front end. So we have this tRPC React. Actually, do they have like a usage with React? Server side, we've already done that. Trick mode, we've always got trick mode enabled. Well, hang on. What does a v config do? That's good. Turn it on. And if you didn't turn it on and you have a project and you turn it on, you're going to realize how much stuff you were letting go by. Okay, so let's set up on the front end, tRPC client server, React query 3. Question, how to implement auth with Cognito and tRPC. Yeah, so that's what this context function is for. So if you are going to use Cognito, which we're doing our auth, we finally picked a date for our auth release. It's going to happen. Let me see. What's the date today? It's not going to happen this next Monday. It's going to happen the Monday after. So in 2 weeks, you should be able to use SST auth and avoid Cognito entirely. But if you are using Cognito, that's what this context function is for. So I haven't actually used it before, so let me see how I can get this working. So you'll get passed into the context function. Or actually, I think I need to define this separately so I can infer the response type. Let me do that real quick. So go back here. Lambda adapter. For the context function, the way to think about this is at the beginning of the request, you can pull stuff out and do any kind of things you need to do for every single tRPC command that's going to happen, and then pass and then kind of reuse that information across the board. Hang on, what's going on here? API gateway event. Okay. Assuming it's gateway event v2, I'm hoping is what it's looking for. Okay. So basically, this context function will run on every single request, and you'll be passed the event. So here, you can do. I haven't used Cognito in a while, but yeah, I'm assuming you'll have some information here, right? So let's say you like pull out the user. JUpdate August 22nd is the SST auth launch. Okay, so let's say you return the user. This context is inferred, and I believe the router takes a context type. If I remember that correctly. So you can do request, context, and there you have the user. So you can like fill the context with whatever you want. Tenant, and it'll all just be here. So this is how you can use Cognito. Just set up Cognito the same way you normally set up. Pull it out from the event here and whatever you need, and every query will have access to it. Oh, well, I need to pass this here. Create context. Is that what I named it? Yeah. Okay. So back to what we were doing before. We need to install usage with React. So let's install this stuff. Run add. Okay, while it's going, let's see what to do after. So if we go into our front end, let's make a tRPC. Oh. Well, SST auth bump SST to 2.0. No, it won't. We're going to do it under a minor release. We're going to rename. So we already have SST.auth as a resource. We're going to rename that to Cognito. Technically a breaking change, but it's just a rename. So you can, if you're already using the auth construct, you should rename that to Cognito. So we're not going to do a 2.0 for that yet. Okay, so let's see, what do we got to do here? So here's the interesting bit, right? So we're going to import the router from the backend. So this should work. There shouldn't really be any issues here, but so we defined it in functions and tRPC thing. Okay, this works. And if we look at this, you get this crazy type, and that's because of that's what it uses to infer. This import type thing you see here, you might have not seen before. The idea here is you're being explicit that I'm only importing a type. I'm never going to be importing anything else from this file. So if there was like a console.log hello here, like this won't make it to your front end. It's kind of explicitly guaranteeing, yes, we're referencing backend code, but we're not really referencing the code. We're just referencing the types. This kind of guarantees like a boundary between the backend and front end. Then you can create a new tRPC client, pass in the router. Okay, it's going pretty smoothly considering I have not done this before. And I'm assuming in main, we're gonna have to wrap. Okay, here's where some of the interesting stuff comes in. Oh, here we go. You see so here's one of the nice things about SST. Just like tRPC, we care about type safety end to end. So if you look at this Vite static site, we're passing in the API URL to it, environment v API URL. That does some, again, it does code generation, so not as slick as tRPC, but in practice, it works pretty well. We generate this for you, and all that does is makes it so that you can do import meta environment, and you have the API URL right there. So whatever environment you pass in, it's going to be available for you here. Now looking to the right, let's see. All right, we do have to initialize React query. We're doing this in a state, which I guess makes sense to control some stuff. Yeah, this isn't usually how I structure things, but let's just do this in the app. What will SST auth login method support? Yeah, so it'll support any OIDC or OAuth provider. So things like Google is an OIDC provider. You can also use it in OAuth mode. So it's great for third-party social login with GitHub, login with Google, whatever that is. We'll also have out-of-the-box support for magic links and pin codes. So magic link, email a link and log in. Pin code, you get a text. You can implement that as you get a text with a code, and you can log in. Can text, email, whatever you want to do there is fine. For username, password, I don't think this 1.0 is going to have a user password version. For most applications, a combination of email login plus social provider login is good enough. The reason we're not doing the user password stuff is that involves persisting the password somewhere. We want to think about that a little bit more and how we want to support that. I think we can provide a user password adapter and provide a callback that gives you a hash password, and it's up to you to save that. So if you're using Dynamo, you save it in Dynamo. If you're using, RDS, save an RDS, using planet scale, save an planet scale, and you'll just need to implement functions to save a username password combination, retrieve a password given a username. And we can do like all the hashing and security stuff for you so that your code isn't even touching the raw password. But that likely is going to come after. So I think we're going to do email and social provider first as V1 launch. And we'll see what the demand is for the username, password stuff. All right. So that is not what I meant to do. Okay, so again, this isn't usually how I structure things, but let's just put it in the app here. Actually, no, this is not good. Do the way I normally structure things. So I usually have app function here. It really just does normal bootstrapping stuff. Rename this after. Use state. Not use React in a bit. Let me see. Query client. Okay, that makes sense. Now we'll initialize a tRPC client. We're going to import the tRPC client we created earlier. So the URL. So we don't need to hard code this. We can do import meta env the API URL / tRPC. That's what the prefix we specified. No headers. All right, we have the tRPC client. Let's just make like a sample app. Sample. How do we do this? So let's return tRPC.provider to provide the context. tRPC client. Query client. So the way this works is React Query, like I said, React Query is excellent for doing anything asynchronous in your front end. I think all of us have written prior to React Query getting traction. We've all done this thing where we do like some kind of use effect, trigger some kind of call to the back end. We have some state that says loading. We render some kind of loader spinner. There's a bunch of times you kind of never do it quite right. So React Query is like a great abstraction around any kind of asynchronous process. The obvious thing for that is like, talking to your backend, but you can also use it for anything asynchronous. So even using some kind of asynchronous web APIs, like talking to IndexedDB or like, pulling up the camera, things like that. It makes sense to use React Query. So tRPC provider, query client provider. So right now we're initializing both tRPC and also React Query. And then our actual app code, which in this case will just be sample. Yeah, React Query from Tansac. And I think is it already renamed to just Query? Because I know Tanner mentioned he's making React Query framework agnostic, which like he did for table. It might be just Tansac Query going forward with the React adapter. All right. I don't know. Let's just make this render. Make sure we didn't mess anything up. Okay. Wow. Okay, that worked. Why is it vertically centered? Weird. Oh, I guess the CSS is already doing some stuff. All right, this is fine. I'm gonna make it bigger so you guys can see. Okay, so now let's use, now the fun part is actually use a query. So now you can do, let's say in this case, we're gonna use one of our queries. If you go here, that's to be an array because first argument. So now you see we have a list of the functions we define in our backend. So we can say hello. And this will, we have type safety here, so it knows that this needs to be a string, right? If we type in a number here, you're gonna get an error. number is not assignable to string. My message, and that is it. So this is gonna, when this component gets mounted, it's gonna send a query to the backend with this. And I'm a little rusty on React, so let me just bear with me here. So if we do hello, we have a nice is loading here. I wouldn't say it's loading. And when it's not loading, we can do hello data dot message, right? So this is, you saw it there. I was able to jump from the front end directly to the back end. So I think if you're using VS Code, it's like control click or command click. I have that mapped to a keyboard shortcut. So you're able to jump right to the back end and see like, oh, okay, there's a message field. So similar to here. Actually, I don't know if this works with primitives here, but nice feature. Cool. So let's actually look at this on the front end. I had this stuck on loading. Let's see what's going on. So we have some errors here. Why are we seeing an error? Okay. Let's actually not make this handle any of these. What are these? Let's just do get requests for now. I think it's because the options requests are being forwarded for cross-origin stuff. Wait a second for this to redeploy. This is a get request, right? Yeah. All right, let's wait for this to deploy. Yeah, we can see that it's sending an options request to the function, which we definitely don't want. Look at some of our earlier things to see the raw formats going back and forth. Yeah, so this is a pretty simple RPC protocol. I actually don't know the answer to this, but I know there's a JSON RPC protocol. I think tRPC more or less, I don't know if it's like to spec, but I think it is like a rough implementation of JSON RPC. So wait for this to finish deploying. Again, whenever you touch your routes, it is a little bit slow. But for the most part, as you can see, like adding new RPC commands, new queries, mutations, whatever, you're not really going to go through this process once you're set up. It's pretty instant once you're set up. And just so I think some people might be coming from the tRPC community. So a little bit of context. So SST is a framework for building full stack serverless applications on AWS. I think when people think of serverless, they usually just think of API and functions, which is a big part of most people's applications. But there's a lot more you need to do as your application gets bigger. So SST contains all kinds of stuff like deploying databases, deploying queues, deploying cron jobs, deploying like event buses. We have a pretty full featured framework for doing all kinds of stuff on AWS. And if you look at the code here, it's as simple as initializing these resources and deploying them. So this static site here is deploying a like edge optimized CloudFront distribution. We do all kinds of stuff that make sure that your static sites are deployed efficiently and performing well. It's kind of like the reason you would go to Vercel or Netlify, like you get a great deployment out of the box. This is a way to do it just all within AWS without really being exposed to the complexity of AWS. Some comments from, we try to conform to JSON RPC 2.0. Yeah, that makes sense. We need to get a Redwood example on there. Yeah, I think I'd love to. We've looked at the Redwood docs a lot. I don't think any of us have actually deployed or used it yet. So yeah, it'd be cool to see if it makes sense to deploy Redwood on top of SST. Can we return nested objects the way GraphQL can? Yeah, so this is an object that you can have like user, blah, etc. The thing that's different between tRPC and GraphQL is GraphQL isn't really letting you return nested objects. It's letting you return a graph of objects. So it's letting you return an object and a relationship to another object and a relationship to another object. So it's very opinionated about the way it thinks about data. And there's benefits to that because your clients can assume a lot about what it's getting and can introspect things and do all sorts of cool things, which is what like Urkel, the GraphQL client we recommend, it like pushes that to the full degree of what you can do. tRPC doesn't have this like relationship model, which is good for situations where you don't really need that. But if you do feel like you're exposing a graph of data and you have like various different entry points and you want people to do all kinds of queries in it, I think GraphQL might make a little more sense. I think so. Alex, the creator of tRPC, is a big fan of GraphQL. So these two things aren't like aggressive alternatives. It's just I like both of them, and I'll use one or the other depending on what I'm doing. Okay, let's see if this fixed it. We refresh now. Nice, this worked. So I don't know if you're going to be able to see on the stream, so I'll actually slow this down here. So we'll do an await. New promise. Let's make this artificially take 3 seconds, right? So if we refresh, you see it's loading. You see the request going up. 3 seconds pass, and then it returns. So you get all these loading states, and you get because it's built on React Query. React Query does a lot of interesting stuff where, like, if this window loses focus and you come back to it, it'll refresh the queries that are on screen. That's why you're seeing it go back up again. It has support for like pagination, like all kinds of interesting things. Like you can even build your own like pseudo normalized cache on it. So React Query is great, and tRPC plus React Query you can get pretty far with. So that is that. So this is an example of a query. So again, remember queries are fetching information from the backend. But let's also do an example of a mutation. So we'll go back to the docs and let's see. Actually, let me see if we can just figure out from the typing here. Again, one of my favorite reasons why I love TypeScript is it reduces your dependence on docs. Like docs are great, but they're not the source of truth. People maintain docs typically separately from the code. So if you can figure stuff out using autocomplete and your code and like the inline docs, tends to be more accurate. So let's kind of explore what's here. Okay, so we have mutation. So I think I'm assuming mutation is going to be something similar. So what are we going to call this mutation? Let's say, I don't know, let's say a to do, because we always do to do examples everywhere. Input, let's say, is going to take a title. That's it. We'll keep it simple for now. Assuming it's going to have a resolver as well. Resolve, async, resolve, request, input, got the title. So I'll return some kind of object here. B1, the title you pass in. Okay, cool. Actually, let me just double check something. Yeah, that makes sense. All right, and I guess this doesn't need to be async. Now if we go to our front end, let's create this create to do tRPC use mutation. This create to do, you see it's auto completing there. And then so that gives us an object which we can do. We can then, is it called execute? How does this work? Mutate. Okay. So here, let's so we might actually, I think we might need to do another deployment for this. Let me check what Magnus did. He wrote this whole great article on tRPC. What did he do for the routes? Okay, I think he just specified a get. Okay, so while we're writing this, I'm just going to go and also do a post handler. I actually don't know if this is what tRPC needs, but just in case, play that while we're going. Okay, so where were we? Create to do. Let's create another button here. Button create. This looks terrible, but whatever. On click. Here we can do, actually make this, yeah, let's actually do the full thing. So we can do create to do, mutate. So you need to pass in arguments here. And look, you got the argument right here. So you can say my new to do. Again, that end-to-end type safety really coming in handy. Let's see if this is implemented yet. Nice. So there, if I go to the reference, so title go to reference, it brings me right to the back end, so I can see what's going on here. You can leave little TS docs here saying, this is the title, and so someone's working on the front end and can jump to the back end and quickly see that. So again, this end-to-end type safety stuff is really great. It's the kind of thing you can't do with the code gen step, right? If you went to reference with a code gen step from here, you wouldn't go to the back end, you would go to the code generated code. So it's one of the advantages of doing a system without code gen. Like I said, our code gen is integrated really well into the GraphQL stuff, so it doesn't feel like there's too many downsides, but there are some minor things. I don't want to say minor. There are some things like this that, if you're really pushing the bar on the best developer experience, some of the code gen stuff does block that. All right, so we have this mutation, and before we even do this, let's do that button should be disabled while create to do is loading. And let's say while create to do is loading, it says creating ... And yeah, okay, let's try this now. Hit create. Boom. You see it go up. This is so it did go up as a push request. Good thing we deployed that. Let's make this a little bit bigger so you can see. Let's look at the payload. So you see that the title going up. Here's a response with the data, ID, title, my to do, and that is available. Just show this here. So create to do data, null to create. Boom. You see it now has the to do we just created. So every time you click it, you see it goes into the creating state. Let me make this a little bit slower so we can see. So again, we can jump straight to there, and we'll do the same thing. Now it needs to be async. Click create. See it goes into the creating state. The request goes up. Hello, etc. You get the response back. So yeah, I think that is probably everything. So just to review, we set up minimal SST application. So this comes with an API gateway. We set up a function to handle tRPC queries. We implemented some tRPC queries and mutations. Then on the front end, we use type inference to create a client that can now talk to your tRPC backend in a completely type safe way. So as you can see, it's a very slick experience. We try to emulate. So this is an experience we try to emulate with our GraphQL stuff. Of course, because of our code gen step, it's not as good. But to me, this is kind of what the best-in-class option there is for end-to-end type safety. I think a lot of people look at tRPC and they say, this, what's the point of this? We've already had stuff like OpenAPI and Swagger, and you can define types in the back end and code gen that into the front end. Yeah, technically it kind of emulates some of this stuff, but the actual developer experience is a lot different. So yeah, if you're using tRPC, it fits in really nicely with SST. So if you're building an application that is going to be a little bit more complicated and can't just sit on, in a Next.js app in Vercel. You want to take advantage of all the constructs that we have. You'll be able to use tRPC pretty easily in SST, and I think it's a great choice for a lot of projects. And okay, I think that is all for me. I'm going to hang around for 2 minutes to see if there's any questions. Let me look through the comments now. Can we use subscriptions? So yeah, I am planning on building a construct in SST for subscriptions. So the reason it doesn't work, like, why can't you just use subscription tRPC? SST and serverless and AWS on serverless, the underlying architecture is called event-driven architecture. The idea behind this is you define functions that react to events. So if there's no event, you have nothing running. There's benefits to this because you're not paying for stuff until an event shows up. And there's a lot of benefits to the stateless approach. And this works for most things. Subscriptions require a stateful service, right? You need something that's going to hold on to the subscription. And it's still pretty event driven, right? When events show up, you want to trigger some kind of publish to various subscriptions that are set up. There's different ways to do this. I think the most obvious way that people do is they use, so in SST, we actually do have a WebSocket gateway. You can probably get tRPC working with a WebSocket gateway, and it'll work fine. The issue with the WebSocket gateway is if you have 1,000 clients connected and you want to broadcast to all of them, the WebSocket gateway is not really meant for these broadcast scenarios. It's meant more for publishing to a small set of clients. We have an idea of how to make a really great real-time system using AWS IoT, which is meant for broadcast scenarios. But we need to build an SST construct that takes advantage of that. And that'll power tRPC subscriptions, and that'll also power GraphQL subscriptions as well. It's something that is very important. We just haven't gotten there yet. How do you set the authorization header while creating the client query if we get the JWT asynchronously? So to clarify, I'm assuming you mean on the front end. Is the front end question? So I'm going to push forward assuming it's a front end question. So if you go to where you initialize, so if you initialize the query here, when you create this client, you can specify additional headers. So the typical flow is, so let's say you're going to store the session in local storage. So you can do something like token equals local storage get item token. And you can say, I don't know, authorization. And when you do check to see the tokens there. So obviously when someone first comes to your app, they're not going to have a token here. So you need to pass in. So you'll need to do a check here to make sure you're not sending in a header if they don't have a token. And then at some point in your application, you're going to need to do an auth handshake. So at some point in your application, you'll check, okay, is this user logged in? We need them to log in. You redirect them to the login page. When they go through the login flow, they might get a token back. That might happen through some kind of API call. That might happen through some redirects. Basically, the result of that, whenever they get the token, you want to put it into local storage or something similar. It might be cookie-based, whatever it is. And then from here, this will be able to fetch that out. So the idea is it's okay if you're getting the JWT asynchronously. You'll need to go through some kind of handshake flow, right? That might be really complicated. It might be putting in a username and password, verifying the username and password, then maybe you get a two-factor authentication step. So you need to put in some kind of code. That might take a couple of steps. The point is at the end of the step, you usually end up with some kind of short-lived token you can reuse a bunch of times. Put that somewhere like local storage, and then you can load that into tRPC. If you have any specific questions around trying to implement this, feel free to ask in Discord, and I can help you out there. Cool. All right. So I think if there's no more questions, let's see, 54 minutes, not bad. Cool. All right. Well, thanks everybody for joining. Hope you learned something and hope you're considering tRPC for something you're building. But outside of that, I'll see you all next week. Have a good rest of your day.